channel, please make sure you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. In today's video, we're going to talk about the arc length and the sector area. So to start off, if you look at this circle, we've got this section of the circle or a piece of the circle that has been cut off. So this is what we call the sector of a circle, right? And then this arc is what we call the arc of the sector of the circle. And then from the center to the circumference, we know that that distance, we call it the radius. So we've got the radius, then we've got the radius. So now, to calculate the arc length, or the length of this arc L, right, L, we say theta over 360 times 2 pi r, right? So what we're doing is that we're taking a fraction of the whole circumference, and this is dependent on the angle at the center, right? So this is for calculating the length of this arc. And now if you're to calculate the area of the sector, or the area of the part that is being cut off from the circle, let's call this A, right? We simply say theta over 360 times pi r squared. So we use this formula. These are the two formulae that we use when we need to calculate the arc length, and as well when we need to calculate the sector area. So now let's move on to look at these questions. The first question, number 1, it requires us to calculate the arc length and the sector area for part A and B. So for part A, calculating the arc length L, we are saying theta over 360, which is 30 over 360 times 2 pi r, right? 2 pi, the radius being 4. So simplifying this, we are saying 30 times 8 pi, 30 times 8 pi, then divided by 360. So we get an answer of 2.09. So we get 2.09 centimeters. So this would be the arc length for part A. And then now the sector area for part A, we are saying that A is equal to theta, which is 30 over 360 times pi r squared, right? So pi r squared, r being 4, 4 squared will give us 16. So pi times 16. And then we get, let's see what we get there. So we're saying 30. We're saying 30 times 16 pi divided by 360. So we get an answer of 4.19. So 4.19 square centimeters. This would be the area of the sector, that we have, right? This is for part A. Now for part B, we're saying arc length L would be theta 45 degrees over 360 times 2 pi, then r being 10, right? So we're saying that 45 times 20 pi, then divided by 360, that will give us 7.85. So this will give us 7.85 centimeters. Then now for the area, this is for part B. Area, we're saying theta over 360, which is 45 over 360 times pi r squared, 10 squared will give us 100. Such that we're saying 45 times 100 pi divided by 360, that will give us 39.3. So this will give us 39.3 square centimeters. So this is how we calculate the arc length and the sector area for part A and part B. Now allow me to move on to number 2. For number 2A and B, we are required to find the area of the shaded region. So now for the area of part A, the shaded region, what we're going to do is that first of all, we need to calculate the area of the whole sector. Right. So now for number 2A, calculating the area of the whole sector. Let me say area of subnode W for the whole sector. We're saying that we've got theta, which is 90 degrees, over 360, right, times pi r squared. Pi, and then r squared being the radius of the whole sector from the center here. We see that it's 5 centimeters. So 5 squared, that will give us a 25, right? Which is most like 25 over 4 pi. So that's the area of the whole sector. And then our area of this unshaded sector, let me call area of the, let me say S for the smaller sector. We're saying that theta 90 degrees over 360 times pi r squared. In this case, the r squared is 4 centimeters. Right, r is 4 centimeters, which means r squared will be 60. Right, then this would be 4 pi. Because we get 1 over 4, then 4 into 16, you get a 4 times the pi. So now area of this shaded region would be the area of the whole sector minus area of the smaller sector, which is 25 over 4 pi minus 4 pi to give us, we set this, 25 over 4 minus 4 times pi. That will give us 7.07. So 7.07 square centimeters. This is the area of the unshaded region. Now, for part B, we are also required to find the area of the unshaded region. So we're going to use the same application. What we're going to do, we're going to say the area of the whole sector minus the area of the smaller sector to find the area of the shaded region. So allow me to erase that part. Okay, so we're saying area of the whole sector, AW, is theta, which is 40 over 360 times pi r squared. Radius of the whole sector is 9. So 9 squared will give us an 81. Right, like that. And then we get 9 pi. Because we shall simplify 40 over 360 to get 1 over 9. Then 9 into 81 will give us a 9. Then area of the smaller sector, AS, would be 40 over 360 times pi, then r squared. R in this case is now 5. So 5 squared will give us a 25, which will give us 25 over 9 pi. So the area of the shaded region would be 9 pi minus 25 over 9 pi, which will give us, let me punch this in the calculator. So 9 minus 25 over 9 in times pi. That will give us 19.5. So 19.5 square centimeters. This would be the area of the shaded region. Now I'd like to attempt number 3. Right? Number 3, there's a lot of variations and a bit of twists. So allow me to erase this whole part. Say number 1, 2, and the stuff in blue. Alright, so I'm going to erase this. Then I can also erase this. Then just leave the formula in black. The formula, and then also this part. Okay, so now for number 3a, we're required to find theta when r is equal to 5 centimeters, L is equal to 7.5 centimeters, and this is what we have. L being the arc length, r being the radius, theta being the angle at the center. So L, given the arc length, we know that arc length L is given by theta over 360 times 2 pi r. Right. Let me pull this like that. So we are going to substitute. L is 7.5, right? 7.5 being equal to theta, which is what we want, over 360 times 2 pi r. 2 pi, then the radius being 5. So simplifying this, already now what we need to do is to make theta the subject of the formula. So we shall multiply both sides by 360, then times 360 that side, then this and this will cancel. So 7.5 times 360 is equal to theta times 10 pi. Then dividing both sides by 10 pi, as we know, pi is just a constant, such that theta would be 7.5 times 360 over 10 pi, which if we simplify that, we're saying 7.5 times 360 divided by 10 pi, we get an answer of 85.9. So theta will be 85.9 degrees. This is for the first part. And then for part B, we are required to find r given theta and L. So making the substitution, we're saying L, 6, is equal to theta, 55 over 360 times 2 pi r. Right? And we're required to find the radius r. So now we need to make r subject of the formula. Now, how are we going to do this? If we multiply by 360 over 55 both sides, right, times 360 over 55, such that this and this will cancel, then that and that will cancel. We get 360 times 6 over 55 being equal to 2 pi r. Then as well, we need to divide both sides by 2 pi. So, such that the radius would be equal to 360 times 6 over 2 pi times 55. So 360 times 6 divided by 2 pi times 55. So we get an answer of 6.25 is the radius. 6.25 centimeters. Yes. So this would be the radius. Now let's move on to look at part C. Part C, we are required to find L given theta and the area. So now what do we need? Right? We're given theta in the area, so it means we need the radius. Right? So now we shall say if area, this will part C, if A, right, which is 50, is equal to theta, which is 72 over 360 times, this is area by the way, pi r squared. And we make r subject of the formula, right? 72 over 360, right, that's 1 over 5. So we're saying 50 is equal to pi r squared over 5. So multiplying both sides by 5 over pi, right, like that, this and this will cancel, then the 5's will cancel, such that r squared is 75 over pi, and then this follows that r will be the square root of 75 over pi, such that if we now need to calculate L, which is the arc length, we're saying theta 72 over 360 times 2 pi r, r being the root of 75 over pi. Right, we'll get an answer of, let's see what we get there. So we're saying 72 pi, we're saying 2 pi times the square root of 75 over pi, right, times 72 over 360. That will give us 6.14. So 6.14 centimeters. This would be the value of L that we want. Now moving on to part D. With part D, we're required to find A given L in R. So it means we need theta. So first of all, we're just simply going to say L11 is equal to theta, which we don't know, over 360, right, times 2 pi r. So 2 pi, and then r, we know the radius is 5.2, Right. This is the equation for finding the arc length. So let's call this one. Because here what I want to do, I need to show you something interesting. We don't have to necessarily go around and round and round in circles. So this is for the arc length. Now for the sector area, we are saying A, which we want, is equal to theta over 360 times pi r squared, 5.2 squared. Then we call this 2. Right? Right. But what do we see here? What we can see is that theta over 360 is common in both equations. So now what if we make, in equation 1, we make this the subject of the formula? It means we're simply dividing both sides by 2 pi times 5.2, which means from equation 1, theta over 360 is equal to 11 over 5.2 times 2, we get 10.4. So 10.4 pi. So this, from equation 1, this is theta over 360. Such that in equation 2, in place of theta over 360, we're now simply putting 11 over 10.4 pi. Such that the area would be now equal to 11 over 10.4 pi times pi 5.2 squared. And of course the pi's will cancel there. And then now we're saying 5.2 squared times 11, then divide that by 10.4, we get an answer of 28.6. So the area will be 28.6 square centimeters, like that. Alright, so this was simply looking at the arc length and the sector area. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.